Hello, everyone, and welcome to Science at Home. We have Gavin back with us today for a new type of interview. This is our Q&A, so you should get to find out a lot more about astronomy itself. So, hi, Gavin.
Hi there.
Gavin studies a lot of different things, but today we're going to be talking about binary stars. Okay, so I'm going to jump right in. Gavin, what is a binary star?
So a binary star is when you have two stars orbiting around each other, essentially. So our sun we don't think the sun has another stellar companion, so it's a single star. So as opposed to, I've got two pieces of a vegetable and and a piece of fruit from my fridge, and so you can just imagine that they are two stars. And what if they're in a binary star, they're orbiting around a common center of gravity. Okay, so about half of all stars are thought to have another stellar companion. So binary stars are actually very common, and you can have binary stars where Alpha Cen is actually a triple star, but its two main stars are orbiting. I forget exactly what the orbital period is, but it's quite short. A few days, I think, but I might be wrong. It might be long. It might be longer than a few days. But Proxima Centauri, which is the closest star to the sun, it's actually kind of orbiting both of these stars. So you can imagine we've got a binary system here, and then we have another star, Proxima Centauri, and it just so happens that at this point in time, the star is closest to the kind of sun and the Earth, but it's got an orbital period of thousands of years.
Right.
And so you can so binary stars in come in a whole shape and guises, and when you have two stars which are both white dwarfs, so they are maybe half the mass of the sun but squeezed into the volume of the Earth, you can get them much closer together. And the most compact binary is 5 minutes. So they go around each other on a 5 minutes. So during this Q&A, which might last 10 minutes, this particular binary star, HM Cancri, will have rotated twice.
Wow, that's really fast.
So that's really fast, and it's so fast that they're emitting lots of gravitational radiation.
Okay. So you mentioned that binary stars are actually a lot more common than you think. How do you actually identify a binary star? They don't look like two stars in the sky, do they?
Well, that's a very good question. So you might know there's a star in the plough. I forget its name, but if you use binoculars or if you've got good eyesight, you'll actually find that it's made up of two binary stars. So you can get, in some cases, if the binary system's quite close, and you can actually physically resolve them into two stars. But generally, they're not separated enough or close enough to detect they're two clear stars.
Mm-hmm.
What you need is spectroscopy. Now, spectroscopy is just a way of splitting up the light of your star. It's just like a rainbow. So when you see a rainbow, that is a spectrum of the sun. So you can imagine having quite a sophisticated instrument on the back of a telescope, and you're getting rainbows of the stars. So some of you might know that if you get a spectrum of the sun, it's split up into dark lines. They're called Fraunhofer lines, after the German scientists who first discovered them. But if you actually get a spectrum over time, and it's a binary star, that the dark lines, will actually show a shift. Okay. As the two stars rotate, they're causing the center of mass of the binary system to change. Okay, and by seeing the effects of the two stars, you'll actually find lines from possibly both stars, so you can see them. You can see the lines going like this.
Okay, yeah.
And it's just a case of the Doppler motion of the two stars. So the star here the line is blue shifted, the line here is red shifted, and they're having a little dance. And if you observe the lines over time, you can actually see the lines, and then you can actually work out what it's called the orbital period of the binary star.
Okay.
And so the orbital period, as I said, can be 5 minutes up to thousands of years.
You would imagine it to be quite long if the stars are so big, but they're not necessarily really long.
Well, I mean, so it depends. So the more compact the star, the more possible it is to get very close together. But if you've got a much larger star, say Betelgeuse was in was in a binary system. Say Betelgeuse is a very big star. It's likely to have another much larger star in a companion, and so the orbital period of these stars would actually be quite long.
Okay. So now we know from previous interviews with various people that stars have a particular life cycle.
Yes.
So is the life cycle of binary stars any different from single stars?
Well, that's a very good question. So, when people model how stars evolve, they normally assume it's just they're just single stars. But you're right. If you've got two stars and they're actually close together, they can start by having a tidal attraction. This can actually cause changes in the structure of both stars, and how that affects the lifetime, the characteristics of the star. That's a very good question because I don't think we actually know the answer to that, because it's actually very different.
Because it happened very differently in different sets of stars.
Yes. So the larger the star, if you're in a binary system, the more likelihood is they would have an effect. If you've got, say, a white dwarf, which is basically very, very dense material, it's going to less likely to have an effect because it's just much more solid.
Okay. So, how do binary stars then become binary? Do they start off as a single star and?
Right. So that's a very good question. So when stars are actually formed, and I must admit I don't really know a great deal about how stars are formed, but they're made in dense gas and dust, and so you can imagine you've got this gas cloud, and you'll have little cores of material which is maybe more dense than its surroundings, but this causes more material to be attracted because there's a gravitational enhancement, so it will attract more gas. And then if you get, if say there's a fragmentary process, you might have a core of gas, and for some reason it might split up into two stars or even more stars. And then you have other cases, say in a globular cluster. So in a globular cluster, you've got big, dense ball of stars, and you might get the case where you've got a star and a star is just passing, kind of orbiting in this globular cluster, and it just gets attracted and starts to orbit another star. So you can get a binary system being made after the event, as it were. But it's probably more likely that binary stars are formed in the same ball of gas and dust at the same time. Okay.
Now, I'm going to go slightly onto a different topic here. I also know that you study exoplanets.
To a degree, yes.
Brilliant. So, can you have planets orbiting a set of stars?
Well, this is a very good question. So this was something which was started to be looked at with Kepler. So there's NASA's spacecraft Kepler, which ran for around 7 or 8 years, and what people were doing there was they were looking at cataclysmic variables. So there, when you've got a white dwarf orbiting another sun-like star, okay, and what the kind of cataclysmic variables or binary stars in particular, the most interesting ones, they're called eclipsing binaries. Okay, so you can imagine stars are orbiting in any kind of angle. It could be orbiting like this, but it could also be orbiting so that they're eclipsing. So if I'm just looking at my camera to see if I'm going to pick up the oranges here. So you can imagine this orange here, it just eclipses this orange here. Okay, so if you're looking at the brightness of the combined system, you'll find a very sharp decrease in the brightness of the binary, and then when it comes back out, bing, you can now see the light again. And by actually timing these eclipses, you can actually see how the orbital period is changing of that binary star. Now, with Kepler, what people were doing with their Kepler and combining it with other data taken previously, they were looking to see how the time of these eclipses changed. And if you've got another body, I'm bringing my onion back again. This if it's a planet, it will have a gravitational pull as it orbits the binary star, and so you'll start. So if that's the case, you'll then get a slight kind of oscillation over time, over years, of when you expect the center of the eclipse to be seen. Okay, so if it's a binary, if the third body is a planet, you'll find this as a sinusoidal modulation, and so this has been quite controversial. But there are a number of cataclysmic variables and other binaries as well, where planets seem to be orbiting both stars. So it's interesting from kind of how do planetary systems evolve when the two stars go through the red giant phase and become wide dwarfs. What happens to these planets? So in some cases, it seems the planets still survived when our sun will become a red giant in whatever it is, 3 or 4 billion years time, and the sun will expand, the earth will get fried, and so some of the planets, according to these CVs, which have been through this stage already, some of the planets seem to have survived.
Okay. Well, thank you very much, Gavin, for having this interview with us. It was really interesting to find out more about binary stars. So I'm going to say goodbye to everyone now. If you'd like to subscribe to our channel, that would be absolutely brilliant. And we're also on Facebook and Instagram. Okay. Bye, everyone, and bye, Gavin. Thanks very much.
Bye.